We begin a new unit today, and as you can see by the title, this is not a topic that's covered in our curriculum, in our textbook. So I will be providing some supplementary materials for you for the next 5 lessons leading up to our next test. So this unit is called the Conic Sections, and where the name conic comes from is, if you can just take a look at our pictures here. If you take what is known as a double nap cone, pictured here, and if you slice the cone with a plane, a flat surface, in certain ways, for example, if you angle the cone so that the plane is parallel to the surface, notice how the plane runs parallel to the outer edge of the cone, then you're going to make the shape of a parabola. And that's going to be the focus of today's lesson. If you slice the cone straight across, the top part of the top cone anyway, just take the plane and go straight across, you will form a circle. And that'll be part of lesson 2. The ellipse is when you angle the cone. You only slice through one of the cones, and instead of going across straight across, you tilt the plane just a little bit. And then our 4th lesson will be on the hyperbola, and you can see how that's made. Hyperbola is really 2 parabolas that open opposite each other. And so we're going to be learning the graphs of each of these, the equations for them. We're going to take a pretty deep study into all 4 of these conic sections, and then lesson 5 will be translations of these. And so let's get started with today's topic, the parabola. Well, we know what parabolas look like when they're graphed. We know we can take a quadratic equation and sketch the graph that's represented. No problem. We've done that in the past. But I want you to think about a parabola and quadratic functions in a little different way. The graph of a parabola is really derived by using 2 different mathematical entities. One of these is an ordered pair that is always inside the mouth of the parabola, and this point inside the mouth, a certain distance away from the vertex, is called the focus. Now, the focus isn't just random. I knew where to place it, and by the time this lesson is over, you'll know where to place the focus as well. You'll know how many units away from the vertex that it should be, and that'll be a part of what we show you in this lesson. But for right now, I'm trying to develop the definition of a parabola. So it involves a point inside the parabola called the focus. And then the other entity that works with this is a line. And in this case, that line would be the same distance away from the vertex, just in the other direction, so that the vertex always sits right in between this point called the focus and this line that is called the directrix. Just take the word direct and put R-I-X. So the official definition of a parabola is this. When I take the distance from focus to any point on the parabola, that is the same distance as going from that point and going to this line called the directrix. So the definition goes like this. It's the set of all points in the plane where the distance from the focus to the parabola is the same as the distance from this point on the parabola to the directrix. So in other words, this distance, maybe I'll call this D1, has to be equal to D2. And that's true no matter what point we come up with. So we collect points by taking a distance, marking it, and then that same distance, it's kind of like those 2 distances converge and create a point on the parabola. And that's got to be true everywhere, okay? That distance has to be the same as that distance. And obviously this would happen an infinite number of times to gather all the points on the parabola. But my main purpose for this slide is to introduce you to two terms that are very important. They come up a lot in our study of parabolas. The focus, which is a point inside the mouth, the directrix, which is a line always outside the parabola, and the vertex will always fall right in between these two mathematical entities. Okay, so this slide, before we get into some specific homework examples, this slide is really one that you should be get familiar with if you're not already. The parent equations, or we could say parent functions for parabolas whose vertex is at the origin. All right, so we already know that for the parabola that opens up, vertex at the origin, the a number for the parent, that would just be 1, but it's a positive number. So this would represent in general the parabola that opens up. When we flip it, this is called a reflection, and this would represent the parabola that opens down. And we're pretty used to seeing those two equations representing these two graphs. But what we're not quite as used to seeing is when we open to the right and to the left. Well, now you notice that the equation, instead of being solved for y when it opens up and down, now it's solved for x for representing when it opens to the right or to the left. So opening to the right, we would say that the equation in general would be x equals ay squared. And when it opens to the left, that makes the number a negative ay squared. Okay, so I'm introducing this to you so you would do yourself a favor just getting more familiar with each of these in general, what they look like, because that's going to be helpful as we study parabolas a little more in depth. Okay, so now let's get to some specifics for the homework. Actually the first two problems, just the first two problems, I want you to do, I'm going to show you how to do these utilizing this definition of a parabola. Okay, so if you notice, the directions are to write an equation for a graph that is the set of all points in the plane that are equidistant from the given point and the given line. So really, this, you could just say, well, that's the definition of a parabola. It is literally those points. So you could paraphrase the instructions and say that we're supposed to write an equation for a graph that basically illustrates the definition of a parabola. Okay, so here's what that means. What I'm going to do, and feel free to do this yourself if it helps, but I'm just going to do a little rough sketch of this particular parabola that's being described. We're told that the focus of this parabola is at the point 0, 3. All right, so there's 0, 3. And the directrix of this parabola is the line y equals negative 3. So what I know so far, based on the location of the focus and the directrix, is that this is a parabola that has a vertex at the origin. I know it's got to be at the origin because the vertex has to be on the same either vertical or horizontal line as the focus. Well, in this case, it's going to be on the same vertical line. And another thing I know is that the reason why I know it's got to be a vertical line, it's got to open up because this parabola, this focus has to be inside the mouth of the parabola. All right, so a couple of things I know. The vertex is right in between. The parabola opens in the opposite direction as the focus, or the directrix, sorry. Focus is inside the mouth. Okay, so what I'm going to do here is I'm just doing a rough sketch so I can illustrate these two distances. Equidistant means same distance. So here's 0, 3. We already plotted that. Here is some point on the parabola, and you don't ever have to identify it specifically. You're just going to show it as a point. It's some xy on the parabola. All right, so this distance identified here between 0, 3, which we call the focus, and really any point on the parabola, I've just called it xy, has to be the same distance as this, from this point to the directrix. So the only thing I know for sure about this directrix is the y-coordinate, because every single point on this line has to have a y of -3. Now where I am specifically, I don't really know, so I'm just going to put some point called x -3. -3 is for sure. X depends on where I am horizontally. Okay, so using the definition, I want to prove, we're going to come up with this equation basically by proving that this distance is the same as this distance. Okay, so from geometry, you may recall the distance formula, and it says you take the two x coordinates from the two-ordered pair, subtract them, square that, do the same thing with the y's. You add those two quantities and then do the square root. So this is the distance formula. So I'm going to actually let one distance equal the other distance. So let's just say I'm going to call this one, just for sake of example, that's distance 1 and this is distance 2. So distance 1 would be found by doing the square root of, I'm going to do the two x's, x minus 0, quantity squared, plus, now I'm going to do the y's, y minus 3, quantity squared. Okay, that's distance 1, and now I'm going to let that equal distance 2. Okay, take the x's and subtract them, and that's pretty easy. X minus x squared. And then the y's, well, I'm subtracting -3, so that makes +3 squared. Okay, well, algebraically, at this point, I need to undo the square root of both sides, so I do that by squaring both sides. So really, at this point, your radicals are gone. But I wanted to show you that this really originates, this whole equation originates from the distance formula. All right, so the radicals have disappeared. And now let's work on simplifying. So x minus 0 squared is just x squared. I got to square this binomial, so that's going to be y squared minus 6y plus 9. Okay, on the right side, obviously that's just 0. And then this is going to be y squared plus 6y plus 9. All right, and just remember that you're always eventually trying to isolate the variable that has the lower degree. All right, so let's see what we can cancel to kind of clean this up a little bit. Looks like I can cancel the y squares. When I subtract y squared from both sides, that makes 0. And I can also cancel the 9's. 9 minus 9 is 0. Okay, well, it looks like what I have left is x squared, and then I've got these two y terms. So I'm going to be solving for y. Y is the lower degree variable, so I'm going to set this up as x squared equals 12y. Just added 6y to both sides. And solving for y, I get y is equal to 1/12 x squared. I think it's a good idea, instead of thinking dividing by 12, multiply by 1/12, because you'll learn in just a little bit the importance of knowing what this number called a is, and that this makes it visible. Okay, so that's my answer, and that's how I got there. So that's the kind of thing that you're going to be doing on problems 1, 2. Now, when you get to numbers 3 and 6, I'm going to show you something different. I'm going to show you something quick, easy, but I want you to have to go through this definition process. You'll do the same thing on the first problem of your test coming up on the conic sections. I'll just go ahead and tell you. Problem number 1 is basically this. I gave you different information, but the process is the same. Okay, so follow that. And I'm going to jump into another example where when you get to numbers 3 and 6 and 7 through 12, you don't have to do the definition like I just did. I'm going to give you a formula, and this formula is so useful when it comes to working with parabolas. It's kind of the shortcut, easy method instead of going through that definition process. But the definition is kind of the why behind this quick and easy formula. Okay, so A is the coefficient for either x squared or y squared. C always represents the distance. And it's distance from vertex to focus. So when you see the letter C in talking about parabolas, it always represents distance, not direction. It's just how many units is it if we counted from the vertex to the focus. Okay, so what I'm told here is in letter A, I'm told that the focus is at the point 5, 0. Well, that tells me that, well, first of all, 5, 0 is on the positive x-axis. And knowing that parabolas, we'll just say it's right here, parabolas have to open up around the focus. Well, this has to be a parabola that opens to the right. I know the directions tell me the vertex is at the origin. So I know when I'm done, I'm going to have an equation that solves for x, because the parabola opens to the right. A has to be positive. So in general, that will be my equation form. So the goal of this problem then is to find out what A is. And when I find A, I drop that number in, and I've got my equation. Well, this formula helps me find A if I know how many units it is from vertex to focus. Well, the focus is at the the vertex is at the origin, and the focus is at 5, 0. Well, obviously that's 5 units, so C is 5. So that makes A 1/20th. So to finish off my answer, x is going to be 1/20th y squared. Okay, letter B. This parabola has to open down. Just think about where the focus is, and the parabola is going to open around it. And the equation for the parabola that opens down looks like this. Okay, so all I have to do is find out what A is. I drop it in. Notice that A, according to this formula, is always going to be positive. What will make my answer negative is the fact that the parabola opens down. So I'm literally just replacing the A. I'm not changing it. It's like the negative is already there. X squared is already here, not changing. All I'm doing is replacing A. All right. So absolute value of A is 1/4 times C. And again, C is not direction, it's just distance. So it's 3 units from the vertex to the focus. So A is 1/12. So here's my final answer. Okay, one more. This parabola opens to the left. Just look at where your focus is. Here's the general equation for a parabola that opens to the left. I just have to find out what A is. Well, it's 2 units from vertex to focus. C is 2. That means A is 1/8. And so my equation for this parabola would be that. Okay, so now we're in a couple of problems. You're going to write an equation of a parabola that opens up, and vertex is at the origin. So we can go ahead and jot this down. This is the parabola that opens up from the origin. And C is 2.5 or 5/2 units from the vertex. So they told us what C is, and now I just have to find out what A is. So absolute value of A is 1/4 times C. All right, so it looks like A is going to be 1/10. And that was easy enough. It opens up, so A has to be positive. Opens up, so the equation is solved for Y. And that's it. We're done with that one. And now we're going to spend the rest of our time taking equations and going the other direction. So this time we're given the equation, and we have to come up with a focus in the directrix. You don't have to graph these. We're going to talk about graphing in the next video. So this is solved for Y, and the A is positive, so it's got to open up. All right, so you don't have to do this little rough sketch, but it opens up, which means that the focus has to be somewhere on this positive y-axis. Well, to find out where, I'm going to go to my trusty formula again, and this time I'm going to use A, which is 1/24, to find C. So you can, at this point, if you can't see it, if it ever gets complicated, you can always just do cross multiplication. Just 4C, that product equals the other. You probably saw that without it, but sometimes it's not quite as easy to see. So I know it's 6 units, that's what C stands for, from the vertex, which is at the origin. By the way, if you don't ever see adding or subtracting in an equation that represents a parabola, the vertex has to be at the origin. So there's no addition or subtraction. Both of these will be at the origin. So here I am. I've got to go straight up because that's the way the parabola opens. I'm going to travel up 6 units. And so my focus then puts me at the point 0, 6. The directrix, I will go to the vertex and go 6 in the opposite direction, and it's going to be a line. And the easy way to remember the directrix, just look at your original equation. If your parabola is y equals, then your directrix should also be y equals. And so the line for the directrix is the horizontal line y equals -6. Okay, let's try this one. Letter B is a parabola that opens to the right. So I'm looking for a focus on the positive x-axis, and then the directrix is going to be, this time it's going to be a vertical line. So once again, use your formula, and you come up with C is 2. So it's 2 units from the vertex going to the right to the focus. So that means the focus is going to be the point 2, 0. And so the directrix has to be the vertical line that starts at the vertex and goes 2 to the left. Remember, since my equation for the parabola is x equals, that's the way I need to write the directrix. Always write the directrix as the equation for either a vertical or a horizontal line. So in this case, it's going to be x equals -2. So there's my answer, 2 answers really, for each of those examples. Okay, that's all we'll do for this. We'll call this part 1, and then part 2 we'll actually get into the graphs, more detail about how the vertex and the focus can be plotted along with the rest of the graph. So that should do it for this lesson, and I hope that helps you out. If you have any questions, just contact me and I'll be glad to help you.